Alright, you're welcome. So as you join, you're welcome. So we want to see to the last section for the solutions of 103 exercises. Okay, so this is still Math 103 exercises. Alright, and like I said, we are embarking on the last section of it, which is from questions 46, yeah, 46 to the end. Okay, and the end I think is around 62, question 62. Alright, so that's what we want to see in this particular section. You are welcome. Okay, so and we are going to begin. So we're starting with the first question, which is 46. And remember, like I said, that section or this section is going to cover binomial expansion. Let me write it. So it's going to cover binomial expansion and functions, so which is the last topic, functions. Okay, so there's going to be an introduction to functions in this particular course. So, and that's what we'll be doing here. Okay, so, and you're welcome. Okay, my pen is beginning to disturb again. So, okay, let's see what I'm looking for. I was looking for this. Okay, so this should be functions. All right, so let's start with the first one. That's question 46, and it says we should write down the binomial expansion of 1 plus 1 over 4x raised to the power of 5, and then they said simplifying all its coefficients. Okay, so first of all we have to write down the expansion and then we'll simplify the coefficients. So what is that going to be? Of course, by formula or by definition of the binomial theorem, we are told that if we have x plus y to the power of n, that it is equal to the sum from r equal to 0 down to n of n combination r, and then multiply by x raised to the power of n minus r multiplied by y raised to the power of r. Excuse me. All right. All right, and this is the definition for binomial expansion. That's the expansion of any binomial term to any given power, positive integer now. All right, so what do we do? This is what we're going to use to expand this. So that means now that meanwhile this particular given term we can write as 1 plus, this is the same thing as x over 4. Of course you know that, okay, so that it will be easier for us, raised to the power of 5. So that means we can bring it down. Our 1 plus x over 4 to the power of 5 is going to be equal to, okay, so we start with 5 combination 0. Of course it will start from 0 of let me remove this and write it better, of and then let it go up a little, okay, of x to the power of 5. In this case our x is 1, so it will be 1 to the power of 5, but of course you know 1 to any power is the same, so it invariably means that this particular expansion is going to have only one term, because there's only one term in the expansion, because 1 to any power will always be 1. So this one will be to the power of 0, then plus, which is also 1 actually, then plus the next one will be 5 combination 1, then 1 to the power of 4. Remember the power will keep reducing, so 1 to the power of 4. Should I be putting it? No need, leave it. And that is multiplied by x over 4 to the power of, this time around this one will be increasing by 1, while this one the power of 1 will be reducing by 1. So this is plus 5 combination 2, 1 to the power of 3, and then x over 4 to the power of 2, plus 5 combination 3, 1 to the power of 2, then x over 4 to the power of 3. All right, then next one, 5 combination 4, permit me to move this way a little, and then x to the power of 1 to the power of 1, and then x over 4 to the power of 4. And finally you will have 5 combination 5, then x over 4 to the power of 5, because 1 will be to the power of 0. All right, so these are the expansion required, the expansion of this particular term that was given to us to expand. Okay, so and then all we need now, according to the question, is to now simplify all the coefficients. So, and to simplify the coefficients, we may actually need to simplify the whole terms, because the particular, that's the B part of this binomial expansion, contains a number. Alright, so you may need to expand everything so that the number can come out, because that number will also form part of the coefficients. Okay, so let's quickly do that. So this is going to give us 5 combination 0, like I said earlier in the previous video. If you go back there, you are going to see where I stated, okay, for the sake of our time, I'm going to restate it here, that when you have n combination 0 is equal to 1, n combination n is equal to 1 also, and then there are other remarks which we are going to see. Okay, the other ones is what we call complementary combinations. If I have n combination r is actually equal to n combination n minus r. That means an instance is that if I have 5 combination 2 is actually equal to 5 combination 5 minus 2, which is 3. Okay, so for example here, this is going to be equal to this. Okay, and this one is going to be equal to this one. Okay, so that's actually what we call it, complementary combinations. Okay, so the reason for that is that it will help you to easily simplify your combinations whenever you have combination problems. Alright, so let's go. So this is 5 combination 0, which is 1 multiplied by anything raised to the power of 0 is also 1. So we have 1 here, plus this one is going to be 5 factorials all over 5 minus 1, which is 4 factorials times 1 factorial, and then multiplied by x over 4. Okay, then plus this one is going to be 5 factorials all over 5 minus 2, which is 3, times 2 factorials, multiplied by, that will give us x squared over 4 squared is 16. Sorry about this. Okay, so now we will have, the next one will be 5 factorials all over, you will see how this is equal to this now. So this is going to give you all over 5 minus 3 is 2 factorials times 3 factorials. So you can see the denominators are actually the same. So that's how both of them will be equal to the same thing. So this will give us s raised to the power 3, and then 4 raised to the power of 3. 4 raised to the power of 3 is what? That's 64. Okay, and then we go to the next one, 5 factorials all over 5 minus 4, which is 1. So you have 1 factorial then times 4 factorials. You can see how this now is equal to this one. Okay, so and that will be multiplied by, remember this is where we are, x raised to the power of 4 all over 4 raised to the power of 4. 4 raised to the power of 4 is 16 times 16, which is 16 squared. That's 256 if I remember very well. And then finally we will have 5 combination 5, I already said, is 1, and that will give us x to the power of 5 all over 4 to the power of 5. Okay, so what does that do for us? So we are done with the expansion. All we need to do now, okay, let me reduce this to be better for us. So all we need to do now is to try to now simplify. According to the question, we should simplify all its coefficients. Okay, so let's go. So this is now going to be equal to, so we have 1 then plus, okay, so if we simplify this, of course this one is going to expand to 5 times 4 factorial, and then this will cancel it, so you just have 5 times x over 4, then plus this one is going to give us, let me do that here, 5 times 4 times 3 factorials all over 3 factorials times 2. 2 factorials is 2. I mean this now. So this is going to cancel out this. And then 2 here is 1. 2 here is 2. So which will give us 10. So we have 10 into x squared over 16. Then plus, remember I said this and this will be the same. So you have 10 into x cubed over 64. And then this is going to be the same thing as this, which is 5 into x raised to power 4 all over 256. And then finally you have x raised to power of 5 all over 4 raised to the power of 5. Okay, which is I think around 1024 if I'm correct. Let me check that. So 256 times 4. Yeah, I'm correct. 1024. That's what it's going to give us. Okay, so now, so you can write that there, 1024. Okay, so that is the value, the expansion, but that's not yet all. So we can try to also, open up that bracket. So we have 1, and then, so let's clearly bring out the coefficient. So this will be 4 over 5x plus this one will be 10 over 16, which you can write as 5 over 8 x squared. Then this one is 10 over 64, which we can write as 5 over 32 s cubed. Then we can write the next one as 5 over 256. Can anything divide there? I think no. So it will be 5 over 256, then x raised to the power of 4, and then finally we have 1 all over 1024, and then x raised to the power of 5. So this is the value of the expansion that we were given to do. Okay, and you can bring in that expansion here, so which is 1 plus x over 4 raised to the power of 5. Okay, so this is the solution to that problem. We have clearly stated the term and we have expanded not just the coefficients, including the terms of the expansion. Okay, and that is that for that number. So we go over to question 47. Okay, so over to question 47, and that question says that we have write down, it's also from binomial expansion. It says write down the binomial expansion for 1 plus 2x raised to the power of 7, and then it says in ascension power. That means beginning from the least power to the highest power, and then in ascension power of x, and then simplifying all coefficients. Okay, just the same question as what we did up here, so we can quickly begin that. So how do we go about it? So recall the formula that I just gave. So we have 1 plus 2x raised to the power of 7. So that's going to be, in that case, our x, from that my formula, our x is 1 and our y is 2y. So we can then go on and do our expansion. And so that's going to be, of course, like I said, since 1 is here, if you raise it to any power, it will still be the same thing. So we can just ignore that one. So here we have 7 combination 0, and then that will be 1 times 2 raised to the power of 2x raised to the power of 0. So we can just bring in this one, even though we also know its powers, it will give us 0. So plus the other one, 7 combination 1, and then 2x to the power of 1. Then the next one, 7 combination 2, and then 2x to the power of 2. Then 7 combination 3, and then 2x to the power of 3, and then 7 combination 4, and we'll have 7 to the power of 4. Okay, let me write that expansion down here instead of going the other way. Okay, so we can do that here. 7 combination 5, then 2x to the power of 5, and 7 combination 6, and then 2x to the power of 6, and finally 7 combination 7, and we have 2x to the power of 7, and you are done. So your job now, according to them, in expanding the coefficients is to now simplify what we have. 7 combination 0, like I said earlier, will be 1, and 2x to the power of 0 is also 1. So we have 1 here. And then the next one is plus 7 combination 1 is actually 7. You know, whenever you have n combination 1 is actually equal to n. Alright, why? Because this is going to give you n factorial all over n minus 1 factorial, then times 1 factorial. And this is the same thing as n factorial can be expanded as n into n minus 1 factorial, and then denominator is still n minus 1 factorial, and this can cancel out. So it will always give you n. And you could have seen it up where we did look at it, where we did 5 factorial 1, 5 combination 1. You saw that we actually got 5. Okay, so it's important that you take note of that. The reason we bring in all of this is to quicken whatever expansion you are doing, all right, so that you don't waste time trying to do the real expansion when you can easily do that, you know, mentally. All right, so let's go in. Now the next one is going to be 7 combination 1, which we said is 7, and then multiply by 2x, then plus 7 combination 2 will be 7 factorial all over 7 minus 2, which is 5 factorial times 2. Let's quickly simplify that. So this is going to give us 7 times 6 times 5 factorial all over 5 factorial times 2. So this will cancel this, and then here will give us 3, which is 21. So we have 21 multiplied by 2x squared is going to be 4x squared. Okay, yeah, that's 2x all squared will give us 4x squared. Then plus we go over to the next one. There's 7 combination 3. 7 combination 3 is going to give us 7 factorial all over 7 minus 3, which is 4 factorial times 3 factorial, and this is equal to 7 times 6 times 5. 4 factorial will cancel, and then 3 factorial is 6, so this will go away. So we have 35, that's here, 35 into, if you open this bracket, you will get 8x cubed. All right, and then let's try to write the last one. Okay, remember, oh, I didn't write the x part of this last one, sorry. I just wrote only the combination. Sorry about that. Okay, so that's supposed to be 2x raised to the power of 4. Sorry. Okay, so if you now simplify this, so we are now going to use complementary combination to finish the remaining. So you see why you need to know all of these things: complementary combination, n combination n, or n combination 1. It helps your work. So because 7 combination 4 is the same thing as 7 combination 3. So here is going to give me 35, and then if I open this, I'm going to get 16x raised to the power of 4. then plus, then come over here. 7 combination 5 is the same thing as 7 combination 2. And what did I get there? What did I get there? Where did I do it? That's this one. So, and I got 21. Okay, so you have 21 into 2 raised to the power 5 is 32, and then x raised to the power of 5. Okay, plus this one, 7 combination 6 is equal to 7 combination 1, and I said that is equal to 7, and that is into 2 raised to the power 6 will give us 64, then times x to the power of 6. And finally, 7 combination 7 is 1, and so you just have 2 raised to the power of 7, which is 128 times x to the power of 7. Okay, so having seen that, all we now need to do is to open our brackets to now get our final coefficients. All right, and that is going to give us that our 1 plus 2x all raised to the power of 7 is equal to, we bring down our 1, then plus this one will be 14x, then plus this times this will give us, I think, 84x squared, then plus, so here we now have larger numbers. 35 times 8 will give us 70 times 4, which is 280x raised to the power of 3, then plus here we have 280 times 2, which is 560x raised to the power of 4, then plus this side we will have 21 times 35 or 32. Okay, let's do that. 21 times 32 gave us 672 x raised to the power of 5, plus 7 times 64 is 448. So we have 448 x raised to the power of 3. And finally, we have, okay, no, I've done this one, right? Is it power 3 raised to the power of 6? Sorry. Where did I get 3? Okay, raised to the power of 6. And then finally, we now have 128. 128 of x raised to the power of 7. And this is your complete expansion with your coefficients showing. All right, and then after that we are now told to use that expansion, this expansion we've gotten, we should use it to now expand, because that's not the end of the question. It says we should use it to expand. Let me write it. Use the expansion, let me call it the B part. Use the expansion, or this expansion, to calculate the value of 0.98 raised to the power of 7. Correct your answer to 4 decimal places. Okay, so we are to correct answer to 4 decimal places. All right, so what is that going to be? We can now take this up a little bit. So, but you know, is this as expansion we are going to use, so I will not need to remove that entirely. So see what that is going to do for us. We will try to see what how we can write 0.98 to give us 2 terms. So what is 0.98 in 2 terms? Okay, so that's so that it will be binomial. All right, what can you think of? I am thinking of 1 minus 0.02. I think that's what will give us 0.98. Yes. Okay, 1.0.02. Okay, so if we make use of this, so it means that Okay. So yeah, and if you compare it to this, you will discover that our x is going to be, look at it there, we can put it in this form, 1 minus, if we bring out 2 here, we are going to have 2, let me use another color to write that. So we are going to have 2 into 0.01. Okay, so that means okay, just follow me, you will get what I'm doing. So that means our 0.98, please remember to put the power, our 0.98 is equal to this, if you are with me. And now we want to put it to look like this, because they said we should use this expansion to simplify this. And to put it to look like this, in fact, we can even move a little bit further. And what's that? To make this to also be addition. If we make this to be addition, then this bracket is going to be negative to balance what we have. So let me even leave that and then write it in another line. So this is the same thing as bracket of 1 plus 2 times minus 0.01, or okay, then everything raised to the power of 7. So I want you to get what I'm trying to achieve now. Okay, let me quickly reduce this. Okay, yeah, no. Okay, I think I needed 1. All right, so what we are trying to do here is to get this expansion to be of this form. That's the internal one. Our 0.98 should look like this. In fact, if you try to simplify this, you see you get 0.98. How? Because this 2 times this is going to give us minus 0.02. And when you bring 1 down, if you subtract this, you are going to get 0.98. Okay, so but why did I have to write it to be in this form? Is so that it will look like what we have up here. You have 1, then you have plus, then 2 times something, and that thing should be our x, so that we can easily substitute into the expansion we have here. So follow what we are going to do now. So that means that our 0.98 raised to the power of 7, which is the same thing as 1 plus 2 into 0.0, into, do I need to write all of this again because of our space? Let me not repeat this, or I could have actually written only the other one. So let's just write that one. That's 1 plus 2 into minus 0.01 all raised to the power of 7 is going to be equal to, remember here now that our x is minus 0.01. So that's what we are going to be substituting here. So that will give us 1 plus, let me use this, 1 plus 14 times 14 times minus 0.01, then plus 84 times minus 0.01 squared. So I can remove that minus and just put 0.01. So meanwhile, it will be good to put this 0.01 in fractional form. So let's go back there. It will make the whole of this work to be very beautiful. So if we put this in fractional form, what is 0.01 in fraction? That's 1 all over 100. Okay, that's 1 over 100. So this is going to be minus 1 all over 100. Okay, all right. Okay, so let's go on. So the next one will be 14 times 1 over minus 1 over 100. 14 times minus 1 over 100. Then plus, what's the next one? 84 times, of course, if the power is even, then the sign will change. Okay, so this is going to be 1 over 100 all raised to the power of, the one of 14 is power 1, so this one is power 2. Then plus, this other one is going to be odd, so the negative power will remain. In fact, that's what we should have done here. This negative power will come out here so that we can be doing this at once. So here is going to be minus, and in this case the same thing will happen. The negative power will come out to change this plus to minus, and so the inside can still be positive. So we have 280. So ordinarily we should have minus here, but I've brought out the minus, so I can still have just 1 over 100 raised to the power of 3. And then I would need to move this way because I need to be seeing this expansion. So the next one is 560. The power is even, so I can just take away the minus, and that's to the power of 4. Okay, let me try to write the rest down here. Plus, okay, the next one should be minus because the power is odd. So minus 672, then 1 all over 100 to the power of 5. Then the next one should be positive. 448 times 1 over 100 to the power of 6. And finally, this one should be negative, which is 128 times 1 over 100 to the power of 7. Okay, so, and that is what we have here. Okay, let me bring this up this way. So we can now arrange this way and then simplify. Remember, they said we should simplify to 4 decimal places. Oh, that means we needed the decimal value. Okay, so permits me to still take that 1 over 100 as 0.01. Then I'm not going to change it here. Maybe in your work you will not need to change it to fractions, so just leave it as 0.01. So in all the brackets you can just have 0.01. all right, so here we will now have 0.01 times, this is 1 minus 0.01 times 14 is going to give us 0.14. Then plus here we will have 84 times 0.01 squared, or let's just multiply it at once. 0.01 squared is equal to 0.001, that's 3 zeros 1, then multiply by 84 is giving us, so the third one is giving us 0.0084. Okay, so minus, we come over here, 0.01 raised to the power of 3, 0.01 to, okay, did I need 0.01 to the power of 3 is 5 zeros, then 1, multiplied by, there we are multiplying by 280. So that is giving us 3 zeros, 0.00028. Then we go over to the other one, plus, okay, in that one is going to be to the power of 4, then multiplied by 560, so which is giving us 0.5 zeros and then 56. All right, and then minus, here we will have to the power of 5 multiplied by 672. Okay, that's giving us 6.72 to the power of 10, times 10 raised to the power of minus 8. Okay, that's a lot of decimal numbers, so which is 0.0000 into 7. Okay, this is 7, then 672. Okay, and then the others. So I will try to get these two at once because of, all right, okay, let's go ahead. I don't need this in okay, let's see. So the next one will be to the power of 6 multiplied by 448. multiplied by 448 is giving us raised to the power of minus 10. So that is going to be 0.9 zeros. This is 3, 6, 9. Then we have 4, 4, 8. And finally, minus the other one to the power of 7 multiplied by 128. So it's giving us to the power of minus 12. So which is 11 zeros. 3, 6, 9, 11. Then 128. Okay, so that's what we have in that expansion, and then we will add everything up. So if we sum everything and subtract where we need to subtract, let's see what that is going to be. So I'm going to type it at once. 1 minus 0.14, then plus 0.0084 minus 0.03028 plus 0.50 5056 minus 0. This one is 70. So I think it was increasing by 2. This one is 70. I think this one was 90, and this one is 11. So the next one is 70. Okay, 70672. Then plus, then 0.90, that's 4689, then 448. Then finally minus 0.11, 1, 2, 3, 4, 5. That's 10 plus 1, 11. Then 128. Okay. So everything, if you subtract and add everything, I got 0.8681 to 4 decimal places according to the requirement of the question. So, and that is the solution to that problem. So that is the solution to that question 47, and that took a lot of our time. Okay, so we can now move on to the next example or the next exercise, which is 49. Okay, and what did 49 say? Okay, so permit me to drag this a little bit. Okay, and then also to increase this again back to my normal size. Right? All right. Okay, so we move to the next thing we have, which is number 48. Okay, so number 48 says find the coefficient, is still on binomial expansion. Find the coefficient of x raised to the power of 4 in the binomial expansion of 1 minus 2x raised to the power of 6. The coefficient of x raised to the power of 4. So the person asking you this question does not expect that you will do the whole expansion. He just expects you to make use of your binomial theorem. So remember we said x plus y raised to the power of n is equal to the sum of r to the equal to 0 up to n of n combination r from x, n minus r, and then y raised to the power r. So you discover that at every point of our expansion, the power of x plus the power of y is always equal to the highest power you are given. Okay, so that's the principle they want you to use here. And then your n is always the upper part of your combination is always n, and the lower part is always your r, which is always the power of the second term. So in other words, if we want to expand this to get x to the power of 4, that means I want the second term, which is 2 minus 2x, to be to the power of 4. So if I take the second term to the power of 4, that means the first term, which is 1, will now be, that means the first term, which is 1, will now be to the power of, remember, it will be n minus the power of the second term. So here will be 2. Forgive me. Okay. This is, let me bring back this. Okay. So this is now going to be to the power of 2. And then what will your combination be? You have seen how I did that arrangement. You know, if you are able to do that all the times, you will be able to get any term that you are asked to get. Okay, so your combination will be n, and our n here is 6. All right, and then your r will be the power of the second term, which in this case is 4. And you are done. So all you need to do is to only expand this term and then pick out the coefficient of x raised to the power of 4. And that's going to give us 6 factorial all over 6 minus 4, which is 2, and then times 4 factorial, multiplied by 1 squared will go away. So remember we said when the power of any number, which is any negative number, is even, then you can throw away the minus. So the minus can go. So we just have 2x raised to the power of 4. And then what's that going to give to us? No, let's go this way. Okay, so that is going to give us, we are going to have 6, we can simplify our 6 factorial as 6 times 5 times 4 factorials, and then that 4 we cancel the 4 down, so you just have times 2 factorial is 2, then multiply by, if you open this bracket, you're going to have 2 raised to the power of 4, which is 16, then x to the power of 4. So here, see what we'll get now. 4 factorial, we take away 4 factorial. 2 here is 1, and 2 here is 3. Okay, so and that is going to give us 3 times 5, which is 15, and then 15 times 16. 15 times 16 is the same thing as 30 times 8. And 30 times 8 should be around 240. So we have 240 x raised to the power of 4. And we are done. Therefore, the coefficient of x raised to the power of 4 as required is equal to 240. And that is a solution for number 48. Okay, so and number 48, okay, no, it's not. I wanted to say that number 48 is the last question on binomial expansion, but no, it is not. Okay, we have number 49 and number 50. So before we now go over to functions, I think this is the end of this page. So let's move over to a new page now. All right, so here we have question 49. All right, and 49 says find the fourth term in the binomial expansion. So we are to find the fourth term. The fourth term in the binomial expansion. What's the binomial expansion there? Okay, in the binomial expansion of x minus k raised to the power of 5. The binomial expansion in descending order of power. Okay, so in this case, they want us to start from the highest power of, okay, where is that? There is other question we handled where they said ascending power. Okay, what did we do there? Was it ascending power or descending power? Where is that question? They said, which number was that? Yeah, number number 47. They said in ascending power. Okay, where is it? See it here. In ascending power, what did we do? Yeah, was it ascending power? Yes, it was ascending power from 1 up. Okay, we are correct. All right, so we go over to where we are, which is 49. 49 is asking for the expansion of this in descending power. Okay, so what's that going to be? In descending power of x. Okay, and that's okay. So solution, we have that we are given x minus k all raised to the power of 5. So following our expansion formula, this is going to be, okay, remember they said the fourth term. Okay, so we don't even need to expand this, expand everything. So the fourth term in descending power of x. So that means x to power 5 down to x to power 4, x to the power of 3, x to the power of 2, and x to the power of 1. So this is what the whole expansion for x is going to be in descending power. And this is the fourth term. So our fourth term is going to contain x to the power of 2, just as I did in number 48. That's what you're going to do here. Our fourth term will contain x to the power of 2, and then what will be the second part of this? That's minus k to the power of 4. Remember, sorry, power of 3. Remember I said that the sum of the two powers will always be equal to the total power that you are given. Okay, so that means, excuse me, so that means this is going to be to the power of 3, and then you will now get your combination, which will be 5 combination. Whatever will be down here will be the power of the second term in your expansion. All right, beautiful. So once you're able to get this, it's easy. You don't need to expand everything to get any term. Let's read it again. Find the fourth term in the binomial expansion of this. Okay, and then they said in descending powers of x. I should have even put that. In descending powers of x. Okay, all right. So, and that's what we have done. So we now have to simplify this. What is 5 combination 3? That's 5 factorial all over 5 minus 3, which is 2 factorial, 3 factorial there. Okay, so we have 3 factorial there, and then all multiplied by our x squared, then multiplied again. This is what do you call it? This is negative, and then this one is odd. So I can just write it as minus k raised to the power of 3. That's what we said earlier. All right, and then if we move this up, we are going to have that this is equal to, if we simplify this, we are going to get 5 times 4, then times 3 factorial. 3 factorial will cancel 3 factorial. So you just have 5 times 4, which is 20, all over 2, multiplied by x squared. Then this minus will come to the front. So you have the minus here, and then you have k raised to the power of 3. And so if this one divides finally, we have minus 10 x squared, or let our k come first. So minus 10 k raised to the power of 3, and then x raised to the power of 2. And that is our fourth term. So we can call it T4. Therefore, our T4 is equal to this. And that is the solution for that number 49. And we move over to number 50. Question 50. Okay, question 50, like I said, happens to be the last question on what do you call it, on our binomial expansion. Okay, and it says find the seventh term. So it looks like number 49 as well. Find the 7th term in the binomial expansion. Let me remove that binomial. There is no time to be writing that. In the expansion of, here we are given x squared minus y raised to the power of 15. Wow, this is huge. So, and that's why you see what we were doing here, all this approach of getting the exact term is the only way out. Imagine getting to expand up to power of 15. Power of 15 is actually going to give you 16 terms, and that's a whole lot. Okay, so solution, what are we going to do here? So we want to get, let me bring down what we are given, x squared minus y to the power of 15. We want to get the 7th term. Let me call it T7. So what is our T7 going to be? Our T7 is going to be, the combination will be 15, and what will be the R here? The R is going to be 6. Remember that combination usually starts from 0. So we have 15, 0, then 15, 1. Okay, so this is the first term. Second term, so it's always 1 less than the position of the term. So that means for 7th term, it's going to be 15 combination 6. All right? Okay, so, and immediately you get your combination, it helps you get the remaining terms. All right, so what's going to be the next one? I'll pick the first term here, which is x squared, and what will be the power? 15 minus 6. That's exactly what we said. So the power is going to be 9. Then we have times, we pick the second term here, which is minus y raised to the power of what is going to be there? This particular 6. And you are done. Expansion of this will give you the value you want. Actually, this is a whole lot, and that's why it's an assignment. So here you have 15 factorial all over 15 minus 6, which is 9 factorial, multiplied by 6 factorial. And then here you have x to the power of 18. Then this is even, so the minus will disappear. So you just have y to the power of 6. Okay, so what will that lead us to? So we just simplify this to get the numerical coefficient. All right, and that is going to be equal to, therefore our 7th term will be equal to, let's try to expand that. That will be 15 times 14 times 13 times 12 times 11 times 10. All right, all over 9 factorial, we cancel 9 factorial, so I don't need to write that. I will just have under here 6 times 5, which is 6 factorial, times 4 times 3 times 2 times 1, if you like. And then that will multiply x to the power of 18, y to the power of 6. Okay, so in simplifying this, let's see. Let me use this one. This 5 times 2 is 10, so it will cancel this one. 6 times, which one should I use there? Let me not use that one. 4 and 3 is 12, it will cancel 12. Okay, then what about 6? 3 here is 2, and 3 here is 5. And finally, 2 here is 1, and 2 here is 7. So we will have 5 times 7, which is 35, times, maybe I should bring that down, 35 times 13 times 11, and that will now multiply this. So we have 35 times 13 times 11, and that's giving us 5,005. So back here, so if we are back here, we have, I can actually bring down this one, x18 and y6. So finally our answer is the 7th term. Is the 7th term we are looking for? Yeah, so the 7th term is equal to 5005 then x to the power of 18 and y to the power of 6, and that is your solution. So you see, for problems like this, you must be able to do the expansion this way, because there's no way you'll be expanding this to the power of 15 if it's, for example, an exam. You will stay in that hall for a very, very long time. Okay, so and that is that for number 50. Okay, so and that is that for number 50, and that covered all the questions on binomial expansion, moving all the way from number 46 down to number 50. And you know, the expansions were demanding, and so it looks like it was a little bit long. Okay, I am thinking of ending this section and then doing the questions on functions, that's from 51 down to 62, in another video. I don't know what you think. I think that will be fine. So permit me to do that way, so that this won't be that long. Okay, I think this is already up to an hour, right? So we will do the other part in the other section. So that means we have about five sections to take care of these particular questions that we are given. All right, see you in the next section as we round up these exercises. Bye.